Hello everybody. I will explain for you a mathematics lesson which is a lotus. What's a lotus? A lotus can be defined as a set of points which share a common property or satisfy a certain condition. In fact, we determine a lotus for a variable point. The lotus is a curve or a straight line that consists of a points that verify the same property. We will discuss many cases. For each case that corresponds for a given property, we will see how the point moves, or on which curve or a straight line does this point varies. I will start with case 1. In this case, we want to discuss a lotus of a point having a constant distance from a fixed point. So we want to learn a lotus of a point having a constant distance, let's say k, from a point which is fixed, let's name it O. For this reason we need 2 points. One is a fixed point and the other is the variable point which we need to find its lotus. So we consider O to be any fixed point. And let M also be any variable point that's at a constant distance from this fixed point O. Okay. First, we want to plot a point O which is fixed. New point. Let's plot it here. We want to rename it. Rename. We should name it O. Okay. But this point O, it should be a fixed point. Fix this object. Okay. Now O is a fixed point. Then we need a point M which is at a constant distance from this point O. We can use segment with fixed length issued from O. Let's say the length is 4 cm in this case. So now we have a point A. Okay, let's name it M as we write in a title. Now M is a variable point which is at a constant distance from a fixed point O. We want to displace point M in order to determine on which line or a curve does this point varies in order to find its lotus. Now we turn on the animation. We should directly see that this point M is moving at a circle of center, which is this fixed point O, and the radius of this circle is equal to the distance from O into M, which is K. So the radius is equal to O M. So we can draw out a conclusion that a lotus of a point having a constant distance from a fixed point is a circle. So M varies on a circle with center O and radius equal to K. So from now we can directly say that each point is at the same distance from a fixed point is vary on a circle whose center is this first point and the radius equal to the distance from the fixed point to the variable point. As we see in this case, the radius is the distance from O into M. In the second case, we will discuss the radius of a point that's equidistant from two fixed points. In this figure, we have 2 points A and B, which are fixed. And we have a point M, which is at a fixed distance from A and B. That's to say, the segment MA equal to segment MB. We also need to displace the point M to detect on which line does this point varies, and we will directly find its locus. We will turn on the animation of M. We will see how M varies. We can see also that whenever M stops, the distance from MA into MB remains constant. In this case, it's 2.18, 2.18. And in this case also, the distance from M into A is equal to the distance from M to B. So whenever M varies on this straight line, the distance from M to into A is equal to the distance from M into B. So M is the distance from I and B. So this is a line where M is varies. If we stop M at a point which is on the segment AB, we see that M is passing through the midpoint of AB. So this straight line is passing through the midpoint of AB. Let us put a point which is at this midpoint and find the angle BCM. We see that this angle is equal to 90 degrees. So this straight line is perpendicular to the segment AB. Also, it passes through its midpoint. So this straight line is the perpendicular bisector of segment AB. So whenever M moves, it will remain at the perpendicular bisector of segment AB. Now we can draw a conclusion that M varies on the perpendicular bisector of segment AB. So we can learn it as a property. If we have MA equal to segment MB, where A and B are two fixed points, then the locus of M is the perpendicular bisector of segment AB. Today I will continue explaining later. Thank you for listening and paying attention.